All right, we're going to check for normality for the different variables. Bam, bam, bam. So when you run a within group ANOVA or a repeated measures, each measurement has to be its own variable. That's the way SPSS is set up. So we're going to check each one of these to see if they're normal, really fast, analyze, descriptives, explore. Get in there, you bastard. Boom. And we're just going to stick all four of them in there. Hold on. Okay, we should probably get the descriptives always. Plots. Again, just a histogram. Normality, check. Don't care about options. Click OK. Here's the output. So we're looking for the Kolmogorov-Smirnov table. And here it is. And nothing was violated on normality. So first one good. Remember that. If the normality checks, if the sig values are less than 0.05, you violated the assumption. If they're greater than 0.05, did not violate. Got it? All right, next one, independence of observation. We are assuming that. The third is what we call sphericity. I put the link in here so you guys can study up on sphericity to see what it exactly means. But we don't use homogeneity of variance in this for a repeated measure ANOVA. So how to check the sphericity is we got to just go ahead and run the ANOVA. So here it comes. Hold on. So this is how you run a repeated measures ANOVA. You go to Analyze, General Linear Model, Repeated Measures. So if some of you guys have the student version of SPSS, this will not show up on there. Too bad. I'm so sorry for you. But click on Repeated Measures. Factor, you can call it whatever you want. I'm just going to call it factor. It's got 4 levels. Add, and then we got to define what the levels are. And the levels are simply going to be each one of these. So hold on. Right, you just highlight them and click them on over. Shkabam. Now we're going to check and see what we want here. Model, nothing there. Contrast, no. Plots, we might want to put plots in there. It's just going to do the different means for you. And post hoc, no post hoc with repeated measures. Save, is there anything under save we want? Nah. No. Okay, options, there is something we want for options. We want the overall. So we're going to go ahead and click the 3 like always. Now we're going to click the homogeneity test, but it's not going to be the homogeneity variance test. It's going to be a sphericity test. The computer knows, right? So if you're going to use a repeated measure, the computer knows which test to run. Click continue, click OK. And here comes output. All right, let's take a look at the output. All right, let's check the assumption of sphericity first. They use a test called the Mauchly Test, so let's find that. Mauchly, there's the 4 variables. There's the means of the 4 variables. And you can tell already, you got 68 and 57. There's going to be a significant difference in there somewhere. But there's the Mauchly Test of sphericity. Again, if this significance value is less than 0.05, you violated. So this did violate the assumption of sphericity. So don't cry over violating sphericity. It is quite common to violate that assumption. So what happens is when it is violated, we simply switch to one of the corrections. We're probably going to use the Hunfeld because it is the easiest one. So what this is going to do is I'm going to show you where to look up the values using the Hunfeld correction because the sphericity assumption was violated. But let's just keep going. All right, so here's where we started in SPSS. There's how many different variables we have. Each one of these is a dependent variable. There's the means of each one's multivariate tests. That can be used in several other tests. So what multivariate means in SPSS is that you have more than one dV. And in a repeated measure, every measurement is considered a dV. So, but don't worry about that one. Sphericity test, we just looked at that. It was violated, but we decided to use the Hunfeld because it is the easiest to get by with. And here's the actual box. What this means is because sphericity was violated, we can't use this first row. We have to go down and use the Hunfeld. So at the Hunfeld level, according to this, the significance is 0.047, which means there was a significant difference between the 4 different measurements. I'll say that again. Because the significance is less than 0.05, we can legally say that there was a significant difference between the 4 measurements. So all you got to do now is write up the results. And they should look something like this. Where are you? Here we go. So you one-way repeated measures ANOVA. See if there's a difference between the 4 different graders on their scoring, and there was. So what you do is you look up the F score where the Hunfelt correction was. Okay, so you're going to use partial degrees of freedom. That tells the reader that you had some kind of correction. So that's it for number 1. MGZ out.